Welcome back. In this screencast, we take a look at something that we don't look at in high school geometry very much at all. Let's take a look at what it might mean to prove that quadrilaterals are congruent. Now, that's a dicey proposition because we're not really skilled with proving quadrilaterals are congruent. We're really skilled at breaking triangles down and showing that they're congruent, but quadrilaterals are a much different animal. When we prove triangles congruent, we know that this works, and 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 so we sort of wonder if everything works. So then we take that over to quadrilaterals, and we wonder if you have four sides of one congruent to four sides of the other, must they be congruent quadrilaterals? If you have quadrilateral A, B, C, D, and you have quadrilateral E, F, G, H, and those are congruent, those are congruent, those are congruent, those are congruent, must it be that A, B, C, D, and E, F, G, H are congruent quadrilaterals? Now think about that for a moment. Try to imagine a quadrilateral where every side is 2 inches long, and then try to imagine a different quadrilateral where every side is 2 inches long. Can you do it? Of course you can. Here's one of them. And here's another one of them, right? Here's a scenario where those are congruent, those are congruent, those are congruent, those are congruent, but side, 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 side doesn't work to prove that quadrilaterals are congruent. It just doesn't work. And so then you start thinking, well, maybe we need an angle in the mix. Maybe we need just a little bit of sass. Like maybe we do. Like if sass is there, is that enough? And so you start thinking, okay, here's a side, here's a side. Then we need an angle and a side, so the angle's between. So we get this thing going on. Maybe it's a right angle. It doesn't matter if it's a right angle, but maybe it is. So now we got A, B, C, we got E, F, G. And then we've got to have this other side that's congruent. So when we draw this like so, we've got to draw GH to be the same length. And the only problem with that is this GH or is this GH or is this GH? They don't really tell us. And so side, angle, side, side, that's not enough. Because even though those are congruent, oh, and those are congruent, it could have been this, it could have been this, so SAS is not enough. But take the same argument. Take the same argument and play this game. You got a side, A, B, E, F. You got an angle and a side, you got an angle and a side, right? There's C, there's G. And then you got another angle and a side, so we open up to an appropriate angle, and there's D. We open up to an appropriate angle so that H is somewhere on this ray, but we know that this has to be congruent to GH, so we know where H has to fall. It's got to be there. And so then we do get congruent quadrilaterals like this, right? Now, we can prove this in a rigorous way, and so I'll give it a try. Let's draw this diagonal in. Let's draw this diagonal in. You can convince yourself that triangle ABC is congruent to triangle EFG, right? Right? Which means we know that this purple diagonal is congruent to that purple diagonal. And we know that this little angle here has to be congruent to this little angle here, which means that this smiley face angle here is congruent to this smiley face angle here. And then go figure, triangle ACD is congruent to triangle EGH, isn't it? And that means that all the pieces here have to match, right? That's got to be congruent to that. Uh, this rainbow angle is congruent to this rainbow angle. This chicken nugget angle is congruent to this chicken. They all got to match. Everybody's got to match. And so quadrilateral ABCD is congruent to quadrilateral EFGH. Now, is the point that you should learn that side angle, side angle, side is a thing? No. The point is that you should know that these quadrilaterals are congruent because we can break them into triangles that we already know how to prove. And I hope that's helpful to you as you've been reading and wondering about congruence of quadrilaterals. And I'll see you when we gather in class.